This is part 2 of our chilled water terminal system series. Today we are going to be looking at DUA's dedicated outdoor air system. As buildings continue to be designed for lower energy use, the resulting reduction in sensible cooling loads presents an economically feasible opportunity for systems that use zone-level sensible only cooling equipments, such as radiant cooling, chilled beams, and terminal units such as FCUs. The common function of these devices is that they are used to provide sensible cooling only and are not able to provide any dehumidification. In this system, the outdoor air required for ventilation is conditioned by a dedicated outdoor air unit. This unit filters, cools, dehumidifies, heats, and may even humidify this outdoor air before distributing it through a duct system to a terminal unit serving each zone. Using a dedicated outdoor air system DUAS to condition outdoor air separately from recirculated air can make it easier to verify that sufficient ventilation airflow reaches each zone, and when that outdoor air is dehumidified so that it is drier than the space, it can help prevent high space humidity levels. In buildings that use zone-level terminals units for cooling and heating, such as VRF water source heat pumps, fan coils, small DX split systems, chilled beams, or sensible cooling terminal units, a separate dedicated outdoor air system is often used to provide ventilation. The DUAS system unit seamlessly pair with another HVAC system to remove ventilation latent and maintain indoor air quality. So we are getting these benefits from the primary HVAC system such as VRF terminals, other terminals unit. We are getting satisfy sensible load, provide comfort cooling, and control by thermostat sensor. With the DUAS, we can meet the outdoor air requirement under all conditions, remove ventilation latent load, maintain high indoor air quality, and it can be controlled by discharge air sensor. In this slide, we are showing the internal components of the DUAS unit, including outside air damper, integral energy recovery wheel, fully intertwined DX coil, sub-cooling coil, single or dual modulating reheat circuit, direct drive plenum fan, heat section, ECM power exhaust, energy efficient compressor, DDC unit controller, and multiple communication options, double wall R13 foam panel construction, which is for the case, direct drive condenser fan. Let's have a look on the DUAS configurations. We have three types of configurations for the DUAS, including directly to each zone, to intake of local HVAC equipment, and last, to plenum near local HVAC equipment. Every type has its advantages and disadvantages, including in this sheet, this slide. Here we have second type, and first type, advantages and disadvantages. Let's have a look on the advantages of directly to each zone. Directly to each zone is directly ventilated to the zone without the need to be connected to the fan or the fan coil or the terminal unit. So it is simply directed to each zone. Easier to ensure required outdoor airflow reaches each zone. Opportunity to cycle off local fan because OA is not distributed through it. Allow dedicated OA system to operate during unoccupied period without needing to operate local fans. Opportunity to downsize local equipment. The disadvantages required installation of additional ductworks and separate diffusers may require multiple diffusers to ensure that outdoor air is adequately dispersed through the zone. Second type. We have the advantages: help ensure required OA reaches each zone, avoid cost and space to install additional ductwork, easier to ensure that OA is adequately dispersed through zone because it's distributed by local fan. This actually was disadvantage in type 1, but here it is advantage because we overcome the disadvantage here. The disadvantages: measurement and balancing is more difficult than if OA delivered directly to zone. Typically required field fabricated plenum to connect OA. Local fan must operate continuously to provide OA during scheduled occupancy, and more. Here we have the advantages: avoid cost and space to install additional ductwork and separate diffuser, but it has many disadvantages. More difficult to ensure required OA reaches each zone. Refer to figure 5E and 5F of ASHRAE 62.1 2010 user manual. Here is figure 5E and here is figure 5F. This is actually disadvantages. Local fan must operate continuously to provide OA during scheduled occupancy, etc. In the dedicated OA system, we have two types of air to be serving the space. We have neutral air and cold air. In the neutral air, we have reheat in the dedicated OA unit, but in the cold air we are directly taking the cold air without the need of reheat, so we are utilizing the cold air coming from the dedicated outdoor air unit. Because of the reheat, we have wasted cooling energy required by the fan coil unit to overcome the additional latent load happened by caused by the reheat of the air before it reaching the space. So in this configuration we have wasted cooling energy. How much this wasted cooling energy compared to the dedicated cold air system? It is approximately 30%, because here we required only fan coil unit with 930 CFM, but in the neutral air system we need, for the same space, we need 1380 CFM. So let's have a look on the this zone. In this zone we have outdoor air 95 Fahrenheit, with 72 dpt, and the required cold air for the dedicated outdoor unit is 71 dbt and 52 dbt at 450 cfm flow required by the dedicated outdoor air unit. And the space requirement are 74 Fahrenheit degree dbt and 55 dpt at 50 percent relative humidity, and the supply air required is 55 Fahrenheit dbt at the flow 1380 cfm, while in the cold air everything is same except the supply air flow. So here we can see it clearly. We need only 930 cfm in the cold air system, while we need 1380 cfm in neutral air system, which is required to reheat the cold air to make it more latent. This requires the zone level terminal unit to have sufficient dehumidification latent capacity to remove this added latent load, and the latent load generated in the space due to people, infiltration, etc. Otherwise, the space humidity level will rise higher than desired. To summarize our session, consider delivering the conditioned outdoor air cold whenever possible, and use recovered energy to reheat only when needed. Providing cold rather than neutral air from the dedicated outdoor air unit offsets a portion of the space cooling loads, allowing the local HVAC units to be downsized and use less energy. Advantages of using DOAS systems includes efficiency, variable speed fan coil control in both the terminal unit and DO unit. Zone sensible cooling is provided with warmer chilled water, typically 56 Fahrenheit to 58 Fahrenheit. Each terminal unit is equipped with a flow measuring damper, making it easy to implement demand control ventilation. Second, comfort. Each terminal unit is controlled by a zone temperature sensor and contains a cooling coil and optionally either a hot water coil or electric heater. Dehumidification is provided by the centralized dedicated OA unit, and when equipped with the humidity sensor, the terminal unit actively adjusts dehumidified airflow from the dedicated OA unit to limit space humidity. Third, flexibility and space required. The dedicated OA unit and its associated ductwork are typically sized for only the minimum ventilation airflow required, a turn requiring less ceiling plenum height and allowing for more usable space inside the building. Reconfiguring a zone often requires moving only the downstream flex duct and supply air diffusers. The sensible cooling terminal units and water piping may not need to be moved. The sensible cooling terminal units can be equipped with either a hot water coil or electrical heater if necessary. It required less maintenance. No condensation occurs at the zone level terminal units, meaning no drain pans to clean and no condensate drain traps and piping lines to install and maintain. Since the cooling coil in each terminal unit operates dry. No filter is required upstream. Thanks for watching. See you again in next sessions. Please like, share and subscribe.